Rob Rasmussen is thinking about playing the piano. 64 electrodes on this EEG cap detect electrical signals inside his brain and send them to be digitized and translated into these real-time traces scrolling across the screen. But what the researchers are really looking for is the mu bands. These are the keys to controlling a prosthetic arm with your mind. The mu bands broadly represent what Rasmussen is thinking about doing with his hands.
One is for his left hand, one is for his right hand.
Mu bands change predictably and reliably, and a volunteer can be trained to manipulate them at will. Rasmussen has been training for almost 4 years to raise and flatten his mu bands to control a mechanical hand. The brain-computer interface is the key to controlling a mechanical arm being developed by the Defense Department in a kind of Manhattan Project to create the next generation of neurally controlled prostheses.
Generally, the prosthetics field has sort of languished with low level of resources. And DARPA came and kick-started the whole thing, kind of like a Manhattan Project.
Spanning 30 organizations across the United States, Canada, and Europe, the project is led by the Johns Hopkins University Applied Physics Lab.
Fundamentally, we do believe it's possible and quite likely that people will be able to retain their position within the military using these limb systems.
2 years into the project, the arm is extremely mechanically sophisticated. But that's not really the point. To make it a truly bionic arm, the wearer needs it not just to look like a real arm, but to react to intentions like a real arm would. The most important piece of this puzzle is the bridge between the prosthetic and the mind. Hopkins researchers are working on several interfaces, from completely non-invasive electrodes placed on the surface of the skin.
But being able to get access to these signals with surface electrodes is the first step. The next step would be use of these wireless implantable myoelectrode sensors. Those sensors can go directly into residual muscle.
Jonathan Cunningham, who lost his right hand in Iraq, is using injectable electrodes. But what if you don't have an arm with residual muscles to put the IMES devices into? A technique called targeted muscle reinnervation reroutes the nerves that once led to the muscles controlling the native arm and opens a direct line between those nerves and the mechanical arm. The most extreme interface is the brain-penetrating electrode. Extremely invasive brain-implanted electrodes interpret the user's direct motor signals. But as yet, the Hopkins project has only placed these electrodes into the brains of rhesus monkeys. That brings us back to Thekor's brain interface.
That using brainwave signals, you can affect prosthetics. And if you think about it, it's the brain, spinal cord, nerves go to the limbs, and then they control the prosthetics.
So this is that 3D macaque brain.
Mm-hmm. Here, the research focuses on brain-penetrating electrodes implanted into the motor cortex of a rhesus monkey at the University of Rochester. When the monkey moves its fingers, its motor neurons fire, the electrodes in its brain record the signals, and the brain-computer interface decodes these spikes. The result is an exact, real-time repetition of the monkey's hand movements. Inspired by the DARPA research on penetrating electrodes, he's now pushing the limits of surface electrodes. So far, his team has gotten to the point where volunteers can open and close a hand just by thinking about it. The reason this works is that Thekor's brain-computer interface doesn't differentiate actual from imagined motor movements. To raise his mu band, Rasmussen thinks of playing the piano.
So Rob, try to get it up. Hold it up. Now down. And as you see, he's controlling the individual fingers there.
I think there'll be long road to making this clinically ubiquitous. So at some point, yes, I can do this wonderful grasp, but if I don't have sensory perception, I don't know what to do with it. Some continuing technology push will be needed. There'll be probably grand challenge problems. It takes one of these magical programs to pull it together.